So now I'm finally ready to get into the case study that I wanted to kind of highlight. And the reason I like this story is there was an NC programmer who was trying to convince his management to invest in force optimization. They said no. They did allow him to go to a force training class. So he took our 2-day course. It's 2 4-hour sessions online. And then as part of that, we open up a force license, and we keep it open for several days afterwards so that somebody can practice with it. This NC programmer took that as an opportunity to go back to the shop and optimize several of their jobs. And then this is the actual presentation that he used to show to management the results that he achieved. And that's why it doesn't follow the template that we were asked to use for these presentations. So one thing I want to point out, we always focus on cycle time and tool life. This NC programmer also focused on the cutting tool temperature and the material temperatures, and that I thought was pretty insightful. So jumping into the results a little bit, this was the first program that he decided to tackle. You can see that he had a cycle time reduction of 37%. And already the machinist was commenting that the toolpath was awesome. Second job he did, and this presentation was very long. I trimmed it down to just a handful of slides in the interest of time. And so you can see that on the second job, 33% cycle time reduction. Third job, again, this is a mold and die shop, 30% cycle time reduction. So he was getting some pretty good results right out of the gate after going through training. Did a hard metal test and saw a 51% reduction in cycle time on the hard metal test. I thought this quote from the machinist was really interesting. This was the best sounding roughing cut I've ever heard in our shop. Back when we used to do live cutting demonstrations when we could all get together, that was the #1 comment that I would hear is people would comment about how different the machine sounds when it's optimized versus not optimized. The non-optimized job would be going rah, rah, and then the optimized job would sound like you were just cutting butter. It was just vroom, vroom. So it really stood out. So this was another test that he did where he used the internal cam optimization. So used the internal cam optimization and actually saved about 30 minutes of cycle time, and then took the optimized, radial chip thinning optimized file and then optimized it with force and saved another 30 minutes. But more importantly, there was this massive spike in forces that was identified in the program that had been optimized with the radial chip thinning optimization. Force automatically saw that spike, pulled all the feed rates down during that time, and so nothing bad happened. That was pretty significant. Some high-res imageries were taken of the tools. I'll go through these quickly. You can see pretty quickly that there was some damage in the non-optimized, no damage in the optimized. Again, we zoom in a little bit more. You can really see some tool chipping. And then they also had some work hardening issues with the unoptimized one. They were looking at the cutting tool temperatures, and with the optimized file, it was 160 to 180 degrees, which they considered ideal, but without it, it was over 300 degrees the cutting tool was getting up to. And that work hardening issue ended up chipping all 4 flutes of the tool that was not optimized, and they only could find 1 flute that was chipped with the optimized version. And in the simulation, they were actually able to go back and find exactly where that work hardening situation was being created. So this was their summary presented to management. Overall, 17 to 45% cycle time reduction, greatly improved tool life, reduced thermal growth. Again, just the fact that they were monitoring temperatures was pretty cool. Improved surface finish and increased operator confidence. And the operator confidence one is another one that I don't think people think about all that much. When I've talked with existing customers about optimizing their jobs, they're like, we can't really do that because the operators are constantly changing our feed rates. They don't trust us to set the right feed rates to begin with, so they're constantly modifying them. And I think this is an opportunity to build that trust between the NC programmers and the machinists. This was the actual Vericut cost justification worksheet that they used to justify the purchase, and just skipping down to the bottom, the ROI was determined to be about 1.4 months. So they did end up, they are now active force users at that shop.